Okay, we are quarter two, week 9, day 1. Find the quotient. We are going to make the 5, a 5 over 1. All right, again, they like giving us the division because it gives us a little extra work to do. We don't get to just multiply across. We have to keep, change, and then flip the second one. So 5 over 1, okay, stays the same. And then the division sign becomes a multiplication sign, and then we do the multiplicative inverse, or the reciprocal of 7 over 8, which makes it 8 over 7. And then again, we'd like to look to see if we can cross-reduce anything. Well, there's nothing we could cross-reduce between the 1 and the 8. Just 1 goes into that. That won't change anything. And nothing goes into both 5 and 7. So we're just going to multiply across. 5 times 8 is 40. 1 times 7 is 7. All right, so how many times does 7 go into 40 without going over? Well, 7 times 6 is 42, so 7 times 5 would probably work there, right? So 7 times 5 is 35. So we've used up 35 of the 40. How much is left over? There's 5 more out of 7. Okay, so there's our answer. 5 and 5/7 is the answer to that division problem. Next, we are going to find the difference, which means we are subtracting, and we are subtracting numbers that have decimals. So we're going to have to line them up. 387.04 minus 128.8. All right, so 4 minus 0 is 4. With the 8, we can't take anything away from 0, so we'll have to borrow from this. 10 minus 8 is 2. All right, can't take 8 away from 6, so we're going to have to borrow from the 8, make it a 7. So 16 minus 8 is 2. 7 minus 2 is 5. And 3 minus 1 is 2. Then we bring down the decimal right where it is. So our answer is 258.24. That would be the difference between those two numbers. Find the missing number of each unit rate. Okay, and again, it's a unit rate because, it is a unit rate because we are going down to the number 1. Okay, so that's why it's called a unit rate. All right, so to get from 3 down to 1, we're going to divide by 3. You could also say we're multiplying by 1/3. Those would both be the same thing. So all you have to do is 36 divided by 3. And that would give you 12. Okay, so this would be a 1/12. All right, how about this one? To get from 8 down to 1, you're going to divide by 8, of course. So 40 divided by 8 is 5. So there we go. We have actually found the unit rates. For this one, we have 1 over 12 on this side and 1 over 5 on this side. Those are equivalent ratios to the previous ratio. All right, there we go for that one. How many decimeters in 2 kilometers? Well, I went ahead and gave you the ratio of how many decimeters there are in 1 kilometer. So what would it take to get from 1 to 2 kilometers? Well, that would be times 2, of course. All right, so then what are we going to do with the 10,000 decimeters? That's going to be times 2. All right, and I'm going to have to basically say, well, 10,000 times 2 would be 20,000, right? So I have to write kind of small because we don't have as much room. Okay, and that would be dm for decimeters. All right, so there's 20,000 decimeters for 2 kilometers since there's 10,000 decimeters for 1 kilometer. And that's all we have for that one. What is the value of 1/3 x plus 7x when x equals 5? All right, so we have 1/3 times 5, which is actually 5 over 1. So I'm just going to go ahead and write it like that. We have to do that first. And then we have 7 times 5. And that's the second thing we have to do. Okay, so let's do the first one. We have 1 times 5, which is 5. 3 times 1, which is 3. Okay, so that takes care of this. And then we have 7 times 5, which is 35. All right, so we have 35 and 5/3. But the 5/3, we can actually turn that into a mixed number. How many times does 3 go into 5? 1 time. Then we've used 3 of the 5, which means we have 2 left over out of 3. So it's 1 2/3 plus 35. So 35 plus 1 is 36. And we have the 2/3. Okay, so that's all we really have to do. This looks a little bit crazy because we have the fraction up there. But if you just take it step by step, it's not too bad. So the answer is 36 and 2/3 as your answer. List 3 values that would make this inequality true. Okay, so we have this sign here, which means less than or equal to, right? Because we've gone over that a few different times now. So let's solve for x. So I'm going to rewrite it down here. 7 plus x is less than or equal to 13. Okay, we need to get x by itself. So to get x by itself, we need to get rid of this 7. Okay, so what's the opposite of operation of what's happening here? Well, we have 7 plus x. The opposite of addition is subtraction. So we're going to subtract 7 from both sides. 7 minus 7, or positive 7 and a negative 7 would give you 0. So the only thing left on this side would be x. So x is less than or equal to, and then we have 13 minus 7, and that equals 6. So x is less than or equal to 6. So just listen to what you were saying there. If it's less than or equal to 6, it means it can be 6. And then could it be 7? No, because 7 is greater than 6. Okay, so it can't be 7, so it has to be like 5 or 4 or 3 or 2 or 1 or 0 or a negative 7 or anything like that. So as long as it is 6, we can include 6 because of this equal sign and less than it. So x is less than or equal to 6. Solve for y. Okay, so we're going to find y by getting y by itself on one side of the equal sign. Okay, since it's a positive y, we can just leave it on that side. But what we need to get rid of is this 8.4. All right, so to get rid of a positive 8.4, and we're adding, you would do the opposite of addition. So you would subtract 8.4 from each side. Okay, so a positive 8.4 and a negative 8.4 would end up being 0, and 0 is nothing. So the only thing we're left on this side of the equal sign is the y. Okay, then we're going to do 10.7 minus 8.4. 7 minus 4 is 3. And then 8 minus 10 is 2. So y is equal to 2.3. So that's called a one-step equation, or one-step solution. So y equals 2.3. All you have to do is get the y by itself, and that's how you would do it. Write the inequality this number line represents. All right, so the number 19 is the number that has the dot above it. So I'm going to just put a 19. And then I can pick any variable I want to. So I'll just put in x, I guess. So we have x and 19. So let's look at this dot. Is that dot colored in? Is it completely colored in? Yes. And if you remember, if it's colored in, that means you can include the 19, which means it's going to have the and equal to part as part of the sign of the inequality. Because it can be 19, it's not excluding 19. All right, then the other part is these numbers to the left, are they larger than 19 or smaller than 19? Well, all of these numbers are less than 19. So whatever number you can put in for x, okay, any of these numbers you can actually put it in for x, those were all going to be less than, and then in this situation, equal to 19. So that would be our our inequality that we're going to do is x is less than or equal to 19. So if you see this type of thing on a number line, that would be the inequality for it. All right, so here is the new item for this week. It is called an input-output table. Okay, so we're going to input a number, and it's going to come out another number. Okay, and there's a rule. I always talk about it as if you were putting something into one side of a machine, something happens to it inside the machine, and then it comes out as something different. But everything that happens inside that machine is the same every single time. It's not going to change what it does. Okay, so we think about these, and we look at the numbers on this side, on the left side. And what do you do with 2 to get the 6? Well, someone might say 2 plus 4. Well, if that's the case, we can go from 2 plus 4 would give you 6, but 4 plus 4 is 8. Okay, so those won't work. Okay, so you can't do a plus 4. And plus, you typically want to keep it multiplication or division. But on an input-output table, that's not always the case. Okay, so what else can you do to get from 2 to 6? The other thing we can do to get from 2 to 6 is times 3, right? 2 times 3 is 6. So let's see if that same rule works for every one of these. 4 times 3, yeah, that gives you 12. 5 times 3 is 15, and 7 times 3 is 21. So the rule for this one is every single time you are multiplying by 3, so the rule is either 3 times x, you can write it that way, or just 3x, or x3, x times 3, any of those things, or 3 times x. There's so many different ways to show multiplication. Anyway, any one of these would be good for the rule because they all mean the same thing. You're going to just take whatever number is on the x side. You're going to multiply it by 3, and that's going to give you the number on the y side. So that is the rule. Basically, it's x times 3 or 3 times x, however you would want to write that. All right, that's all for that one.